Before jumping into the coefficient of restitution, we must talk about other important equations first. These are our handy-dandy projectile and kinematic equations. As you can see, there are three of them. Depending on what is given and what is needed, you can solve for your unknowns in a problem. This includes distances, velocities, and times. The coefficient of restitution equation gives us a ratio of final and initial velocities between two objects. This can be very helpful in finding extra unknown velocities that will help solve our problems. The conservation of linear momentum is also used alongside of the coefficient of restitution equation, as the energy before and after a collision of two particles is the same.
We are now moving on to the impacts within each trial. As you may know, an impact is the collision of two bodies causing internal impulsive forces. This leads to a special case of conservation of linear momentum and that mechanical energy is not usually conserved. We have two types of impacts that we will cover, which are central impacts and oblique impacts. Central impacts are when the velocities of two objects are along the quote-unquote line of impact. Our experiments are considered to be central impacts as the floor does not have an initial velocity. As you can see from the figure, the objects will go through 5 phases within the central impact. We start with the before impact, as object A in the floor has a velocity that is in the same direction. And then for phase 2, we have the deformation impulse, which is when the objects first touch each other. Now we have max deformation, which is when the objects are stuck together and move with one velocity. And that gets us to the restitution impulse, which is the moment right before the objects will detach from one another and then will contain their own velocities, concluded by the after impact phase. All of this takes place within milliseconds, so it is very hard to see with the naked eye.
A girl throws a ball with a horizontal velocity of v equals 8 feet per second. The E, or coefficient of restitution, between the ball and the ground is 0.8. Find the velocity after the ball rebounds. This is a multi-step problem where you start with two projectile motion equations. The first one relating the position of the ball before being dropped to time. In this case, you can see that time equals 0.431 seconds. Using time, you then add it to an additional projectile motion equation to get the final velocity. Now, you take the final velocity and you put it into the coefficient of restitution equation. Because we were given the coefficient of restitution of 0.8, we can go ahead and include Vy into the equation. We know that the ground has a starting and ending velocity of 0 since it's not moving, and so we can use this equation to determine Va2. In this case, Va2 is 11.12 feet per second. Next, we can determine the velocity x1. In this case, we use the conservation of linear momentum problem.
Tracker is a good software that can help us find our initial and final velocities of an impact. Here I will show you how to use it. So we can first start by creating a new point mass for the object that's falling. In this case, it will be a little piggy. We can track it by using auto tracker and putting the point mass on the piggy, using Control-Shift on your keyboard and putting it on your mass. After this, you can search and it will auto search all the points on the object or the particle, and it will calculate the velocities for you on the plot shown on the right. This software is useful because it can help us find the velocities that we don't know in the coefficient of restitution equation.